In the last few examples, we have been graphing functions f of x equals x to some power p. We started with x to the 1/3, the cubed root of x, and x to the 1/2, the square root of x, which are on our graph to the right. And while they're not fractional exponents, we've also seen the graphs of x to the first power, which is just x, and x squared. More recently, we found the graph of f of x equals x to the 3/2 power, and f of x equals x to the 2/3 power, as well as f of x equals x to the 3/4 power. Now notice, if p is a fraction with an even denominator, then we have to take an even root, such as a square root or a fourth root. So we need x to be bigger than or equal to 0. In other words, not all of our functions are defined on the left-hand side of the graph. So let's zoom in on the first quadrant where all of our functions are defined to get a better picture. One important thing to notice is that for x bigger than 1, the graphs increase as p gets bigger. For instance, x squared is bigger than x to the 3/2, which is bigger than x to the first power, which is bigger than x to the 3/4, and so on down the line. And also notice that for x less than 1, the graph decreases as p gets bigger. In other words, between 0 and 1, the graph of x squared is below the graph of x to the 3/2, which is below the graph of x to the first, and so on. So if we were to graph the function f of x equals x to the 5/4, where would we expect this to be? Well, 5/4 is 1 1/4. It's bigger than 1, but it's smaller than x to the 3/2, which is 1 1/2. So we would expect the graph of f of x equals x to the 5/4 to be wedged between the graph of x to the 3/2 and x to the first power. We can use this idea to graph x to many powers without having to start from scratch.